All right, looking at a integration problem. This was sent to me by one of my former students and was like, how the heck do you do this? And I looked at it and I was also wondering how the heck you do this, but I figured it out. The first thing I notice in this problem is I see a natural log of x inside parentheses with something happening to it. So my initial thought is, I wonder what happens if I let u equal the natural log of x and I try some u sub, which can work because the derivative of natural log x is 1 over x dx, and while it's kind of hidden and wonky in here, I do see a 1 over x in here. There are just also extra x's down there, so I'm going to rewrite the problem as 1 to 7 of the natural log of x squared over x squared, and I'm going to pull out one of those x's to serve as my du. So now that I see my du in the problem, I can proceed with u substitution, plugging u in for the natural log of x, and du will replace the 1 over x dx. The problem is there is still an x squared down here, or there's still an x in the denominator that has not been accounted for, and we will account for that by solving for x in my u equals the natural log of x equation. So let's start substituting. Let me get rid of all this stuff. Let's see, so we have the antiderivative of u squared over x squared, and I'm going to do something with that x in just a minute. The 1 over x dx will become a du, and if u is equal to the natural log of x, that means x would equal e to the u, and so I'm going to plug in e to the u in the denominator. That is being squared, and that's the same thing as e to the 2u. I will actually bring that up and make that e to the negative 2u times u squared du, and there is my substitution. And once you do that substitution, this now has become an integration by parts problem where I have to be careful. Usually I like to use u and v prime for my parts setup. However, u has already been taken in my u substitution, so I'm going to say I have an a and a v prime, and my a will be the u squared, and my v prime will be e to the negative 2u. And then I can take the derivative of my a all the way down to 0. I believe this is called the tabular method for integration by parts. So I'll take my u, or my a, all the way down to 0. I will do the antiderivative of my v prime the same number of times. So that's going to be negative 1/2 e to the negative 2u. The next antiderivative would be negative 1/4 e to the negative 2u. And finally, I will have negative 1/8 e to the negative 2u. And I guess technically I started with the third derivative of v, then the second, then the first, and then v. And now I will finally finish up the antiderivative, multiplying down diagonally with the positive product of a and v double prime. Then I'll subtract the product of a prime v prime, and then I'll add the product of a double prime v, giving me u squared, take that back, negative 1/2 u squared e to the negative 2u minus 2 times negative 1/4 will be plus 1/2 u e to the negative 2u plus 2 times negative 1/8, which would be minus 1/4 e to the negative 2u. So there is our antiderivative, and now we need to go back and remember that we did do substitution, and way up here, back up, u is equal to the natural log of x, and so now I need to replace all of those u's with natural log of x, and I think I'll do that on the next page. Give me a little bit more room. There we go. So that antiderivative led to this in terms of u. And I'm trying to decide, do I want to plug in the natural log of x for all of my u's, or do I want to change my limits of integration? Oh geez, this is going to be a booger with arithmetic as well. I think I'm going to change my limits of integration. So if x is equal to 1, which is my lower limit of integration, u is going to be the natural log of 1. Oh, that's sexy. That's 0. So I'm going to evaluate this from 0. And then if x is equal to 7, that will lead me to a u value of the natural log of 7, and that's not quite as cute. So I'll evaluate up to the natural log of 7. And I think at the same time, I'm going to take these e to the negative 2u's and stick them in the denominators of all of this. So maybe I'll rewrite that answer to get rid of the negative exponents. There we go. And now it's time to substitute the natural log of 7 and 0. So let's substitute those real quick, and then we'll play arithmetic. There we are, substituting the natural log of 7, and the 0, 0 obviously was kind of nice, not kind of, very nice. And we ended up with just that for u is equal to 0. Over here I have a lot of e to the 2 natural log 7s. I'm going to simplify that over here on the side. E to the 2 natural log of 7. You remember one of the properties of logs, you can take that exponent of 2, pull that up and the coefficient of 2, make that an exponent, and that's the same thing as e to the, whoops, forgot the e to the natural log of 7 squared, which is 49, and e to the natural log of 49 is just equal to 49. So all of these denominators right here that have e to the 2 ln 7, e to the 2 ln 7 is equal to 49. Holy cow, this is ugly. And so I'm left with negative natural log of 7 squared over 2 times 49, which is 98. So I'm going to replace, all those with 49. So over 98 plus the natural log of 7 over 98 minus 1 over 4 times 49, which would be 196. Is that right? 6, yeah, that's 196. And then all of that plus 1/4. And boy, that's bad. That's a really ugly, stupid answer. And I would stop there. Sadly, the person who sent me this is doing this online, and they have to punch this answer, assuming I've done this correctly. They have to punch this answer in on a website, and they have to hope the formatting is exactly right. I don't know, maybe the directions told them to round. I don't know what's going on. This thing's ugly. I feel pretty good about that. I'm gonna stop. And I lied, I'm not stopping. I made a sign error. I punched this in on my TI Inspire just to check my answer, and I did make a sign error. Everything was correct, except right here where I was doing my antiderivatives of v. I forgot right here that when I divide by that negative 2, this will be a positive 1/4. And then the negative 1/8 is correct. So this term right here will become negative. And over here, that means this is negative, this is negative, this is negative. And it does happen that if you combine the negative 1 over 196 and 1/4, that ends up being a positive 12/49. And that is the correct answer. So the negative natural log of 7 squared over 98 plus the natural log of 7 over 98 plus 12/49 is the right answer. And there you have it.